Hello everyone, today we're going to go over the blind 75 in C++, and today we're working with the problem top k frequent elements. Now, before we get started, feel free to pause the video. For whenever we are breaking down these questions, we always need to ask ourselves the 4 questions: what the input's going to be, what data structure / algorithm / technique to use, what to do with the data, and what our output is going to be. Feel free to pause the video for a moment to be able to write out all these questions if you're following along. I just have them already set up right here. Again, feel free to pause. We need to ask ourselves all these 4 questions. Alright, and now, in order to break down our question, given an integer array nums and an integer k, return the k most frequent elements. You may return the answer in any order. Well, we already know exactly what our input's going to be. It's going to be this, and it looks like we need to return the k most frequent elements. Pretty self-explanatory. We solved 2 of our questions. Now let's look at the example to be able to understand exactly what we were working with. So if we have a given array of nums and the k most frequent elements, it looks like it's just asking us to return the 2 most frequent elements. So we have 1, 2, 3 ones. We have 3 ones accordingly. Then we have, it looks like, 2 2s and just 1 3. So there are 3 1s and 2 2s. The 2 most frequent elements are, yes, 1 and 2. And it looks like that we need to return this in an array, as they are expected. And it looks like this edge case, if it's just 1 and the 1 most frequent element, it will just be 1. Also some more constraints as well. Okay, it's the range 1, the number of unique elements in the array, so it starts at 1. And follow up, your algorithm's time complexity must run better than O n log n, where n is the array's size. Okay, so that's also another thing to take into consideration. And then the data structure and technique that I will be introducing your folks to is really just going to be a hash map with a priority queue. And to explain the data structures between the two over exactly how we're using them is that a hash map is much like in the case of a series of lockers that one would have. If one has a key that needs to connect to a specific locker, the value, you have a key value pair to be able to open your locker, and that is how the hash map is typically designed. And then the priority queue, for the most part, is that queues in general are much like in the case of grocery store lines, where it's going to be last in, first out on like a stack, where a stack is typically like a stack of plates, and it will be first in, first out. So that's just one thing to keep in mind, just for the visualization for the two, just by principle. And so to be able to go over the steps of how we're going to solve this problem step by step, is that first we're going to initialize a hash map to count the frequency of elements available. And then 2, we're going to create a min heap to keep track of the top k frequent elements. Our min heap is really just a priority queue. And then we are going to initialize the variable for the result. Step 4, we are going to loop through the array and count the frequency of each element using the hash map. And for step 5, we are going to loop through the hash map and add each element frequency pair to the min heap. If the size of the heap becomes greater than k, we're going to remove the top, the smallest element from the heap, hence a priority queue. And then we will also pop out I was going to pop all the elements from the heap and add them to our result, ultimately returning our result. So to get things off, for step 1, what we are going to be doing is initialize a hash map to count the frequency of the elements. So this is how it's done. Unordered map int, and then a count. And now for the next part, what we'll be doing in order to count the frequency of the elements, we're going to be doing a for each loop for int num of nums that we get from our vector up here. We're going to increment our count accordingly of nums. It will just be num in this case because we are doing a for each loop to count everything that we have already visited and the frequency of their elements. And for step 2, we're going to create a min heap to keep track of everything, which is just a priority queue. Int vector pair int make sure I get this right. And then we're gonna have greater for a pair of int. Yep, right over here. It should be the third one right here. And then we'll have our min heap. Now, for the next step that we will do, is that this would be steps 4 or 5. Is that for 1, we're going to loop through the hash map and add each element to the pair. So we're going to have auto and I for the frequency of all of the all the elements that we have visited. So what we were doing is that we are going to push the frequency inside dot second. Alright, dot first. If the, this would be 5a. If the min heap size is going to be greater than k, then what we will be doing is that we're going to be popping. We're keeping track of all the frequency of the elements. The smallest element. From the heap, because we want the great. We want k amount of elements, not the smallest. We're going to do step 6. So what we're going to be doing is that we're going to have a vector called result of k number of frequency of elements. And so we're going to be scanning throughout the rest of our given array relative to the k number of elements, and then I is going to be greater than or equal to 0 because we're starting at the very end. Then we're going to decrease our way, and then we'll have our result of I equal to the min heap at the top with our second. Then we're going to have our min heap pop accordingly to be able to have the k most frequent elements. And finally, we will return our result. Oh. We're scanning our queue. Priority queue in step 6, and this is how we scan our queue. We're going to start at the end. I'm going to put all these notes in the comment section to be able to help further explain. But this should be the steps that we would need or have our problem already solved. So let me just run this. All right, it passes all the test cases and submit. All right, and just to be able to give a rundown on our space and time complexity for the following is that the time complexity for our solution is going to be O of n log of k, where n refers to the length of the array, and this is because first we traverse the array to count the frequency of the elements, which is going to be O of n, and then we traverse the hash map and perform the push and pop operations in the min heap, which is going to be log of k. Hence, the total time complexity is going to be O of n log of k. Well, the space complexity for our following solution is going to be O of n, where n is referring to the length of the array, and this is because in the worst case scenario, all elements in the array are distinct, and both the hash map and the min heap will contain all these elements, hence the space complexity will be O of n. And yeah, okay, and this is the top k frequent elements. Thanks again for taking time to watch this. If you found this helpful, feel free to like and subscribe, and if you have any other questions, feel free to put them in the comment section. And as always, take care. Cheers. Bye-bye.